Welcome back to yet another little video about probability. This one is about repeated actions, and there's hard versions and easy versions. This is the easy version. We'll do the hard one later. Okay, well, the situation we're going to look at is two-child families. So suppose the chance of having a girl is 50%, a boy is also 50%. That means they're equally likely. The probability of each is 1/2. There are three family configurations, 2 girls, 2 boys, and 1 each. What are the probabilities of these outcomes? Here's the wrong answer, 1/3 each. Why is this wrong? That's the subject of this video. We're going to analyze it with exactly the same kind of diagram we used before, an area diagram. So we start with a box representing all possibilities. Key thing in order to get it right is to look at each child separately. So we start with the first child. There's a 50% chance it's a boy and a 50% chance it's a girl. Now we're going to have to bring in the second child, and so we're going to modify the diagram kind of like we did before. We're going to pull this out, and we're going to go like that. And now we start to bring in the second child. We can have either a boy or a girl for the second child, which means that there's a chance for 2 boys, a chance for 2 girls. Then this one is a boy first and a girl second, and this one is a girl first and a boy second. If we look at these, we can analyze what are the probabilities of having 0, 1, or 2 boys. Here is 2 boys. Here are the 2 ways that you can get 1 boy and 1 girl. And here is 2 girls. So the 2 boys is a quarter, 1 each is a half, and the 2 girls is a quarter. Notice that this is so different from the 1/3 each. Now, we're going to look at it again using the area model and really paying attention to the areas. So here is boy first followed by a girl, older brother, younger sister. The probability of each is 1/2. So you multiply them together to get the area. 1/2 times 1/2 is 1/4. That is, the probability of boy followed by girl is 1/4, like that. Now, why can we multiply? Because they're independent. The sex of the first child doesn't affect the sex of the other, at least that's our assumption. If we want to look at the other corner, girl first, then a boy, it's also a quarter, so the probability of older sister, younger brother is 1/4, like in the diagram. If I want to find the probability of 1 girl plus 1 boy, I have to add both probabilities, 1/4 plus 1/4, which is a half. Wait a minute, why do I add? Because they're mutually exclusive. Remember this from like 2 videos ago? That is, you can't have an older sister and a younger brother and an older brother and a younger sister at the same time. Okay, here's the Connect-O-Rama. Last time we had a little video about blue and red dice and rolling a blue 4. And this time we're looking at first child and second child. These 2 diagrams are very similar because they are, in fact, exactly really the same situation. The only difference here is that the one we've just done is it seems like the boy-girl thing is the same sort of choice for the first child as the second child. That's true. All right, so here is a potential pitfall, and we alluded to this back at the first slide. Suppose we're analyzing this from the beginning. We say, okay, look, first child could be a boy or a girl, second child could be a boy or a girl. What are the possible number of boys in the family? And you say, oh, 0, 1, or 2. That's the possible number of boys. Perhaps they're all equally likely. So we'd say 0, 1, and 2 boys are all equally likely. The probability of each number is 1/3. Problem is, this is wrong. The thing that's different about it, about this 0, 1, and 2, is that getting 0 boys or 1 boy or 2 boys is really the result of a combination of events. And this combination is the combination of having the first boy or girl, having the second boy or girl. This turns out to be exactly the same reason why rolling a 7 with 2 dice is more likely than rolling a 10 or something like that, because it's involving a combination of the first die roll and the second die roll. So Don't make that mistake. The probability of 2 boys is 1/4. 2 girls is 1/4. 1 each. Probability is 1/2. See you later.